Metal powders used for parts production can be a combination of various elemental particles or pre-alloyed powder. If elemental powder is used, each of the ingredients that will comprise the desired part are mixed in proper proportion into a uniform blend. With pre-alloyed powder, the proper proportion of ingredients is already present in each particle. In either case, additives such as binders and lubricants are usually added. The powder is then consolidated in molds or dies, shaping and densifying it into a compact of the desired part. At this point, the part, or compact, is in a green state, where the powder particles are just lightly joined together. In this state, the parts have a so-called green strength, which is usually only sufficient for handling purposes. The parts are then transferred to a sintering furnace. During sintering, parts are heated at a temperature below the melting point or range of the base metal, but high enough to metallurgically bond the individual particles. Sintering further densifies the parts, increasing strength. Final part density is extremely important. Although controlled porosity is required and achievable for certain parts, the performance of structural parts increases directly with increasing density. The common methods of consolidating and shaping metal powder for parts production include mechanical pressing, injection molding, and isostatic pressing. Most parts are made by mechanical pressing and sintering. Parts are usually small to moderate in size and can be simple or complex in shape. They can be very thin or thick and can also have one or more levels, shallow or deep holes, and various other details. Parts produced by mechanical pressing can be net or near net in shape and have very close tolerances. Part production rates are high, from several hundred to thousands of parts per hour. In mechanical pressing, the powder is automatically gravity-fed into the die of a mechanical or hydraulic press and consolidated to a specific density. Pressures of 10 to 60 tons per square inch are created by the vertical action of an upper punch or by the double action of an upper and lower punch. Pressing is typically at room temperature, although elevated temperatures can also be used. Core rods are used inside the die to control formation of holes parallel to the direction of pressing. If the part being made is thin and uniform in height, the powder can be pressed from one side by the upper punch. When that punch withdraws, a lower punch raises the part out of the die. The part is then ejected by the wiping action of the powder feed chute, which also wipes powder for the next piece into the die. Ejection from the press can also be accomplished using automated handling equipment. The density of pressed powder tends to decrease along part height as the distance between the compacting punch and die increases. To produce more uniform density, thick parts are compacted by a set of upper and lower punches. After pressing, parts are transferred to the sintering furnace. Sintering furnaces include preheat, high heat sintering, and cool down zones, each having a controlled atmosphere. Depending on the base metal of the part, the atmosphere of the sintering furnace may be endothermic, which is composed mainly of hydrogen, nitrogen, and carbon monoxide. Exothermic, which is composed of nitrogen mainly. Dissociated ammonia, which is hydrogen and nitrogen. Or entirely hydrogen, vacuum, or inert gas. To ensure proper sintering, the heating rate, maximum sintering temperature, time at the sintering temperature, cooling rate, and furnace atmosphere must be closely controlled.